All right, let's look at this problem called longest cycle in a graph. So we are given a directed graph which has n nodes, and one of the things that's mentioned is that there is only at most one outbound edge from a node. If there are no outbound edges from the node, then this edge is of I will be -1. Otherwise, this edges of I will represent the node to which it has an outbound edge. Like in this example, every node has an outbound edge. 1 to 3, 0 to 3, 3 to 2, 2 to 4, and 4 to 3. And this is a cycle. In this case, we can see 0 has an outbound edge, 2 has an outbound edge, 3 has an outbound edge, 1 does not have an outbound edge. So that's why for 1 it's -1. And there is no cycle here, so we return -1. Now, one thing to note here is that essentially we can do DFS and find a cycle. However, we need to find the longest cycle. So for every cycle that we find, need to know uh, sort of what was the length of the cycle. And to do that, while we are traversing some path, we'll maybe save the indexes of every node in each path, right? So for example, let's take a look at this example. So the example that's given to us, we go 1 points to 3, 0 points to 3, 3 points to 2, 2 goes to 4, 4 goes to 3. We will start from 0. So we'll give it let's say index 1 in current path, this will give index 2 in current path, this will give index 3 in current path, this will give index 4 in current path, and 2 is already in the path that we know. Sorry, 3. 4 goes to 3, already in the path at index 2. So from 0, so essentially from where I come to a node which is already in the path, I get its index 4 minus 2 equals to 2 plus 1. So these are the number of edges, which is 1, 2, right? And this is the third edge, so we do plus 1 as well. So essentially you go parent index minus self index plus 1. This is the length of the cycle. This is when self is sort of is set. That's the case. Basically, when there is a cycle, this will be the logic. So let's build on that. Another bit that I want to sort of discuss is once a node has been visited, like once 3 has been visited, and like from 0, then 1 when you visit 1 to from again 3, any cycle or no cycle from 3 has already been processed. You don't need to process again, just stop here to sort of optimize the algorithm. So let's take care of these two approaches, these two uh, uh, sort of ideas, and build the solution. All right, so we want to do a DFS, we want to find the longest cycle, and if there's no cycle found, return -1. So int max cycle length start as -1, and we have to return max cycle length. That's fine. Now what else? So to do DFS, we need to maintain a visited array. So let's do that. Boolean visited array. So new Boolean of size edges dot length. So that's done. Also, you want to get the size of the cycle. We need to maintain indexing sort of where a node was found in the current path, right? So uh, we'll do int index in current path equals to new, and again adjust dot length. Now we go through each node. So I equals to 0, I less than n, I plus plus. If it's not visited, then it's interesting, because if it's not visited, then you have to handle it. And the way to handle it would be you do DFS. Okay, so you do max cycle length equals to math.max. One says whatever this is. Let us assume DFS returns the max cycle length, and in DFS you pass your um edges, you pass your visited, you pass index and current path, you pass the source, and where you came from. In this case, where you came from, let's say, is same to begin with. All right, now let's build this DFS logic. So int DFS, we take the edges and we take this visited array, we take index and current path. What else do we need? Um, Source and int where it came from. Okay, I mean, we could do this as, let's say, -1 as well, doesn't really matter, right? Or same. So now let's do this. If the node that we're looking at, if it's already visited, okay, so if it's already visited, uh, then there are two cases. One, it was visited in this current path, it was visited and it's in the current path, or it's not in the current path, right? So if uh, so this zero means it was visited in some other path. That means it has already been processed. No need to process it again. There is not a new cycle. Any cycle that has been found is already been found. So in this case, we'll return -1. And the else case would be this is first time visited uh, in this current path. It's in the current path and visited. So in that case, we need to do, we will return parent minus child minus this guy plus 1. So these are two cases. And other cases if it's not visited, right? If it's not visited, then you mark it visited and you set the index and current path of parent. Now here there is a problem if you return -1. That's why I wanted to return I here. So because it will always be initialized to 0. So 0 plus 1 would be 1, right? So it would be not this, sorry. It would be uh, initially if you pass same source and parent as same, both of their indexes would be 0. So 0 plus 1, so that means first time when you start. So for this guy 0, index will be set to 1. For 3, index will be set to 2 and so on. All right, now you want to do something else as well, which is after you're done with this, you want to do DFS again. Max cycle length you will get by doing further DFS. You pass your edges, visited, you pass your index and current path, and you go to its parent, right? Its outbound edge, which is edges of source, and the parent. Now, where is you go from the source? There is one more case. If it does not have an edge, which can be handled here, if If it does not have an edge, then this will be -1, in which case you can just return -1. All right, so this is handled. Now before you return this max cycle length, you also want to remove this guy from current path because this has been fully handled. So now reset it to 0 for other paths. Uh, just reset it to 0. Right, that's my entire logic. Let's run the code. Compilation error, let's try and fix. There is no n, it's edges.length. Alright, let's see if there are more errors. There are more. Let's try to figure out what's the issue here. Cannot find some symbol. Okay, it doesn't know what this index is. Maybe it's nothing. So there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. More compilation errors. Let's try and fix those. Typo. And both test cases are accepted. Let's submit. And it does get accepted. All right, so that's it.